but I stopped because I noticed that a lot of people were taking it seriously. So I stopped that. I work for a company called Hazelcast. Who knows about Hazelcast? Nobody knows about Hazelcast. Well, that's interesting. So Hazelcast is an in-memory data grid, meaning we take all the data, and it's very good idea for caching stuff. And now we have a new product called Jet, which is all about stream processing. So we build upon the in-memory data grid, and then we stream your data. Well, if you're interested, you can have a look. So for today, the agenda is the following. First, I will try to introduce the thing. I mean, let's talk about microservices. Who here does microservices? A few hands, that's good. Then we'll see what problems do we find in microservices architecture. Then we will talk about a solution called the circuit breaker and how Istio implements the circuit breaker and how Hystrix or Resilience for J, because there will be a choice at some point, implement the circuit breaker, and then I will have some demo. So I'm super lazy. This is a definition of microservices found on Martin's Follows blog. And basically, in general, everybody does everything at the beginning. Oh, it doesn't work. Yes, no, yes, no. Like that. Okay, up until this point. So people who told me they were doing microservices, now do you have microservices organized around business capabilities? Yes? No? Yes? Great. Next point, products, not projects. That is the hardest point. Who here has product and no project? One. That's good enough. In general, there are like 1, 2, 3. When I have like 3 hands in the room, it's like amazing. Because, well, that's not my definition. So in a sense, we are not doing microservices because everything we do is a project. So there is a beginning, and more importantly, there is an end. And when there is an end, meaning there is a schedule that we need more budget or less budget or whatever. More stuff. Microservices. Again, on Martin's Follow blog, you must be this told to do microservices. What I found out is we are tech people. Who here is a developer, architect, tech guy? Okay, who is not? What are you doing in this room? It's a tech room, huh? Anyway, so most of us are tech guys. And when we talk about microservices, basically we approach microservices architecture from like a technical point of view. That makes sense. The problem, as I mentioned just before, is some of the aspects of microservices, they are not tech related. They are like management related, organizational related. And the biggest problem with microservices is you cannot approach it from a tech perspective and say, as a tech leader, as a solution architect, or even as a CTO, hey, we will need now a microservice architecture, and we will do it in our own corner. All developers will do microservices, and the business will stay as usual. That doesn't work like that. People who advertise for microservices, they say, hey, we will use Conway's law. Who knows about Conway's law? Well, just read the description. It's here. Basically, they say that your architecture will reflect your organization. That's fine. So they will use Conway's law to say, hey, we will have like 2 pizza teams who will be self-organized. And then we will have microservices architecture. In case you are wondering, the important guy in this picture is not me, who is laughing just there, but is Conway. This is the guy. His Twitter handle is Conway's Law, so he has a law in his own name. That would be great to have the same. Too young for that. So I'm super happy to have met this guy. And in some organization, this is how people are doing microservices. This is the real way to do microservices. Basically, you take one guy from product management, couple of guys from QA, couple of guys from dev, couple of guys from everything, and you make those self-organized 2 pizza team, and everything is fine, then you have microservices. Make sense? But this is how probably your company is structured. You're organized like that. And because of Conway's law, you can never, ever have microservices. And who sits at the top of each silo? Come on. I know it's a bad word, but you can tell it here. Who sits at the top of each silo? A manager. Yeah, a manager. Where are the managers here? No more managers, because the team, they know what they can do, they know how to organize themselves, they don't need nobody to tell them. They do their work because, yeah, that's their job. So basically, the only people who can change your organization are the people who will lose the most. Who here does microservices now? And of course, there is another problem with microservices, or the hype around microservices, is that, hey, since 10 years, we have a lot of idiots working on this architecture. Everybody who worked on it made a really bad mess. So now we have this like ugly monolith. But let's remove everything. Starts from a blank sheet and everything will be fine. And of course, we will do it using microservices, because it was already so hard doing something mediocre with a monolith. It will be much, much easier doing that with microservices. That rings a bell? So, in my world, semantics are very important. So I will try to avoid the word microservices, and I will talk about web services, because I believe that most of us are doing web services anyway. It's how we communicate with different systems. And of course, there is Murphy's law, and yeah, anything that can go wrong will go wrong. And now you apply that to an architecture that is highly distributed. Anybody can recognize this? I've been an architect. This is a UML diagram. This is how architects work. We do nice diagrams with boxes and arrows on boards, and everything is fine from here. And the problem with that diagram is that it can apply to a simple API call, or it can apply to a microservice REST call, or to a web service SOAP call, or to anything. So on the whiteboard, we don't care. That's an implementation detail. That's for developers to find out. It works. But then we go on distributed computing, if we go the web service way. And there are a lot of fallacies about distributed computing. And just start with the first. The network is reliable. Of course, the network is not reliable. It will fail. It's not if it fails, it's when it will fail. So if we have a simple web service architecture, let's say we have two clients, one front web service and one back web service. I don't know what they do, but that's nice. What happens is, if everything works out, we have these like requests that go from one of the clients, and I've lost my Red Bull, so I don't know where it is. Now it's here. And then it's forwarded to B, and everything is fine. And then the client gets the request, everything is fine. But now, for some reason, B gets down. Perhaps B is up, perhaps it's the network that is down between F and B, you don't know. But at some point, F is not able to contact B anymore. So what happens is that all of your requests, they get stuck on the front web service. What happens next? Yeah, F goes down. Woohoo! And a simple, stupid problem in one of your web service can propagate all over your architecture, and all your architecture goes boom. So that's not something you want. So there is something called the circuit breaker. And the circuit breaker is just like in your house. If there is too much power in your electricity wires, then one of the wires just melts away and opens the circuit so that your house doesn't burn. So we could devise the same for microservice architecture. Sorry, web service architecture, so that if a mistake happens somewhere, then we isolate the problem in this area, and the rest can still continue to work as usual. Again, UML diagrams, architects, like from a design point of view, it's quite easy. At the beginning, everything is fine, and then we make calls, and we make calls, and we make calls. Sometimes a call might fail, but if it's only one call, that's not a problem. The problem is like when repeated call fail. So everything is fine, and then some point, something bad happens, and we repeatedly fail. Okay, then we open the circuit. At this point, if we just say, hey, we open the circuit, that means that you have a system that once it breaks, will stay broken all the time. We don't want that. So after a time, we might say, okay, we try to make tentative calls. If it fails again, the circuit breaker stays open. But if it succeeds again, then we have a self-healing distributed system, because we are back to the normal flow of events. Make sense to you? Okay. So how do we configure it? We have a number of configuration options. For example, we can configure the number of failing calls before we open the circuit. Pretty good idea. Or how about the elapsed time strategy? So when do we try to close the circuit breaker again? Perhaps we can have a fixed time. Perhaps we can have a doubling. Perhaps we can have like log 2. I don't know. There is a strategy. How many successful calls do we need to close the circuit breaker again? These are all configuration options. But I forgot the most important option. Who can guess what is the most important strategy, what's the most important parameter that we need to configure? Yes, not only the page, yes, 1 point. Not the page, but what do you do when it fails? When it times out or it fails, what do you do? What's the fallback result? Because you have this client that expects the results. If it breaks, what do we return? I've been working in e-commerce at some point in my life, and I think it's a great, great example. So basically, imagine that you have an e-commerce shop that is not built as a monolith, but as different services. So we have the recommendation web service, which basically tells people, hey, if you have been on Amazon, you know about it. Hey, people who bought this also bought that, so they try to upsell as much as possible. Then you've got the pricing web service, telling you how much it costs. Yeah, if you have never worked in e-commerce, you tend to think that prices, they are fixed. They are not. Depends on the time of the day, depends on your profile, depends whether the business wants to sell a certain product, depends on the phase of the moon, depends on a lot of stuff. Payment web service, because probably you are not doing the payment yourself, but you are calling like a payment external provider. And probably because you have a web service architecture, you probably need to log everything, so you have a logging web service. So let's see how the fallback applies in every one of those cases. So login is the easiest. If the logging web service doesn't answer, that's a problem for the people who basically monitor the system, but for the customer, it doesn't care. You can still sell, business is happy, so not a problem. Recommendation. Recommendation starts to be a bit harder. What product do we recommend by default if the recommendation engine service is down or the network not available? Perhaps we can hard code some products that are like bestsellers. You always want to sell them. Perhaps you return an empty set and you don't try to upsell at all. Perhaps we cache the latest one. What would be your choice? What is the best option here? Sorry? iPhone. iPhone, yeah. If you sell clothes, that's always a solid choice. What strategy would you recommend? So I've been a consultant, the answer is always, it depends. So the right answer is it depends. And in that case, it depends. You have no clue what's the best strategy. Actually, you are the tech guy. You should just provide the tools for the business to decide. And it's up to the business to decide what is the best strategy. For you, it's easy to return nothing. I'm a developer. I know it's easy. Caching is a bit harder. But in that case, you just can propose some options and let the business decide. Still, you have a lot of options. Pricing gets even harder, because even with recommendation, you can say, we return nothing. It's an empty set, we don't try to upsell. Pricing? I've been in e-commerce, and the people, they always want to sell. Actually, they prefer to sell at a slightly outdated price than at no price at all. So they want to sell. So again, couple of options here. You can cache the results. You can take the data from another source. You can do a lot of stuff. What strategy? It depends. Payment. That's the highest limit, because here the options are pretty limited. But when you think about it, they are not that limited. You could accept the order and send an invoice. That's a pretty solid option if you are in Germany or in Switzerland. In France or in Southern Europe, you wouldn't try that because you will never get the money. I'm French, I know what I'm talking about. So yeah, in Switzerland it would work, because if you don't pay something, then afterwards you get into a lawsuit. It won't work. It will work only once. Another option would be to send an email to the people afterwards saying, hey, we didn't receive your payment in the first time, please do that and that and that. I mean, there are a lot of options. Again, options are not the same than before, but you still have a lot of options. And from everything I've told, basically, you can have two typologies of strategy. The first strategy is, we don't care. If something bad happens, well, it's fire and forget for logging, or it's an empty recommendation set. It's fine. And then we have the other kind typology of strategy, which says, we must do something related to the business logic. So there is this black box option, which is good for service meshes. And there is this white box option, which is really good for libraries because you need to be inside the code itself. So service meshes. Service meshes are magical, like Kubernetes is magical, will solve all your problems. But if you still have problems, then you put service meshes on top and they will solve all your remaining problems. Of course. The good thing about service meshes is basically they try to offload a lot of the responsibilities of an application in a web service architecture to something that is external. So in that case, they are really good. Like load balancing, for example. Before, you had client load balancing. Who here comes from the Java world? Not that many. Okay, a few hands. Like you could use Ribbon, for example, to have this client load balancing stuff. And then you had one library for every feature that you wanted. Now you try to remove all those libraries, you put them in the service mesh, and then your application becomes very, very thin. And if you are in the Kubernetes world, then Istio is right now what is pushed around. So it's open source, it's built on top of Kubernetes. But actually, just under the hood is just the envoy proxy. It's nothing mind-blowing. It just hijacks all network communication. And it uses the sidecar pattern. So basically, when you deploy a container into a pod, then Istio will also deploy its own container alongside of it. So you don't need to explicitly do it every time. It will be by default. So you deploy a container, you've got two containers. From a very, very high perspective, that is how Istio works. Basically, as I mentioned, it hijacks every network communication. So in your pods, there is your own container, it deployed its own container, and in order for service A to communicate outside, then it must go through the proxy. And the same goes for inbound communication. If service B listens to some port, then like Istio and Envoy will like intercept everything. Configuration for a circuit breaker is very, very easy with Istio. Basically, you've got this like destination rule stuff, and you've got 4 parameters. First parameter is, like I mentioned before, how many like failed calls you must make in order for the circuit breaker to open. And then what's the sliding window interval for those failures to happen. And then how long will the circuit breaker stay open. And here, that's something interesting. It's because we are at the architectural level. There probably won't be a single container in the pod. There will probably like multiple containers in multiple pods. And so probably, in general, you say it's better to have like, perhaps to keep a few of them, even if they are not properly working, than to remove all of them. So you might want to keep some of them, even if they are failing sometimes. And because Istio works at this container level, then you see the whole pool of containers. And the biggest problem with Istio is, of course, you've got no fallback. So if it fails, it's up to you. Now I can talk about either Hystrix or resilience for J. Who wants Hystrix? 1, 2, 3, 4. Resilience for J? 1. Shit, I prepared for resilience for J. Okay, I will talk about Hystrix. So Hystrix is a library. So who is aware that Hystrix is not under active development anymore? 1 person. So that's perhaps the reason. Now that you know that it's not under active development anymore, do you still want me to talk about Hystrix? Just a question. I have on the slide, really, but I just want to make sure that you make an enlightened choice. Still Hystrix? Okay, again, one more time. Hystrix. Okay, resilience for J. Now there are more people. Okay. That's what I thought. You will get the slides anyway, where I have everything. So again, Hystrix is now not under active development. It was a very successful library provided by Netflix, integrated with Spring. But I don't know the reason, but they stopped developing it. And now there is this library called Resilience for J, which is heavily built on Java, and more importantly, Java 8 and functional programming. And Resilience for J offers a lot of features. Among them is a circuit breaker. The interesting stuff is that for every feature, it's a dedicated dependency. It's a dedicated jar. So if you want multiple features, you need to integrate them like independently. It uses Java 8 functional intervals. So basically, it is based on function composition. Netflix was very object-oriented, but Resilience for J is only about function composition. So basically, you have this function f, and then you have this function j, and j calls f of x, which makes you the result. So it's very mathematically based. It uses under the hood, and you can use it also, a functional programming library of Java called Bevor. Previously, it was called Java Slang, but because of trademarks, they had to rename it. The problems of Resilience for J is that you need to be quite familiar with functional programming. If you have been doing like Spring and object-oriented programming and all that stuff for a long time, you need to change the way you look at stuff. So basically, if you're just out of studies, it's probably better. And the problem, I mean, it's the opposite of Istio. That Istio was very good at knowing about the architecture and knowing the number of nodes and whatever. But here, since we are inside the service, we have no view of the big picture. You just know what happens inside the application. Okay, I will have a little demo, because otherwise it's just slideware that is not quite interesting. I have created an application where I have two applications actually. So they are all Spring Boot Kotlin application. Basically, I have a pricing application and I have a shop application. So the shop application will ask for the price to the pricing application for like an item. How do I compute the price? Well, it's very, very stupid. I hashcode the ID and I jitter it a bit so that it's not always making big random leaps, but it keeps around a certain ceiling and bottom. More importantly, when I make the request, I will do a simulate network. So the simulate network stuff will do that after a certain like grace count, so a number of times, and I configured it here to be 10. So after 10 counts, it will like sleep. So do a timeout for like 5 seconds, 4 times out of 5. So I introduce failing in my application. And on the opposite side, I have the caller, which is the shop stuff. And basically, I'm using the Spring template to like call this URL. And also, when I get the result, I will cache it. So here, it's my fallback. Okay? And now I have these different calls that, again, are functionally composed together. So I use something called a time limiter, because I want, if a time limit is reached, to fail fast after a time, once the circuit breaker is open. And here I want to say that if I reach the timeout, I will open the circuit, and afterwards I won't make the call. I will just return very, very fast the result I got from the previous call. And if everything is fine, I just return the result. It's written in Kotlin. I'm sorry for that. I'm a Kotlin lover, but I think you understand the basic flow of it. And I will write everything down in the console, especially if it comes from the cache or if it comes from the real stuff. So I will start the pricing engine. And I will start the shop application. And now I have a simple script that basically repeatedly calls the shop. Okay? Works for you? Good. So the first 10 calls are like free. They work very well. And they tell me, hey, they come from the service. So I'm making the calls, everything is fine, it's fast, I'm super happy, my microservice architecture starts getting down. And now I must wait some time to get the results. And after a time, you will see that now, for example, now it's getting fast because the timeout limit has been the first few times the time limit has been exceeded, and after it failed repeatedly, it opened the circuit breaker, and now I get the stuff from the cache very, very fast. And now I still gets me always the same price, until I get, again, the one of the original price. Now the question becomes, hey, here I should return like 131, and I still got different numbers from the price, because I still fill in the cache, meanwhile, under the cover. So sometimes you get difference in the price you get from the cache. It's because even if it fails, I still get the result after some time. Oops. 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 Okay. this is it. So you can read about my blog, you can follow me on Twitter, and more importantly, if you are a Java developer or not, you can get the repository from GitHub and play with it and check how it works under the cover. Because yeah, I admit that it was a bit fast, perhaps. So now we have time for some questions. Are there any questions?